everyone, it's Bob Crossan. I am the Vice President of Content Strategy for the Endeavor Business Media Water and Energy Groups, a division of Endeavor B2B, joined today by Tom McCurdy, Director of Environmental Sales at Aerzen. Thank you so much for being here, Tom.
Absolutely, it's good to see you again.
Of course, it's great to see you. Now we're going to be talking here about AERprocess a little bit,
Yes.
but first things first, why would a wastewater treatment plant want to automate their aeration processes?
All right, so it's primarily about energy. The first thing is that the energy required to provide the air into an aeration system in a wastewater treatment plant can be as much as 50 to 60% of the electric bill for the entire plant. And a lot of design engineers that are designing capital improvement projects, that are upgrading blowers, are all interested in high efficiency blowers. And so it just kind of makes sense, if you're going to be providing high efficiency blowers, why not make the best use out of that high efficiency so that that 50 to 60% can start to get cut down. So it really comes down to the energy savings that are available.
Yeah. So how exactly then is AERprocess a little bit different from other things out there?
There have been a number of historic ways that designing or consulting engineers have designed the aeration control systems, and a lot of the traditional ones have been energy wasters, in that if you look at an aeration basin with multiple zones of aeration, the typical old style way of aerating those basins was with what they call a cascading loops. So you have multiple zones, and each one has a DO probe, and that DO probe basically controls that valve that lets the air into the system. Now we'll repeat that however many times, and then the net effect on the air header is what changes the amount of air that goes, that's provided from the blowers. And because of the way that operates, that pressure in the header that those blowers see can be 1 to 2 psi higher than what the system actually needs. Meaning what the system would need would be based on the depth of the water and whatever losses that there are in the pipes and in the diffusers. And so to do that, you're basically wasting another 10 to 15%. So how do you get to knock that down? And part of what this AERprocess does is it utilizes most open valve, flow-based delivery of the air into the system, which means that if you have multiple zones and each one has its own dissolved oxygen level, whatever deficit and all that, whatever zone needs the most air has its valve open the most. So there's still going to be some feathering in the valves, but the net effect on that air header pressure is going to be much lower. It's going to be much closer to that basically natural system curve of the system. So that's part of it. The rest of it is in how the rate of change in the system gets managed. Meaning, over the course of a day or a week or whatever, you'll have different demands, whether it's a change in flow or a change in the strength of the waste coming in, or even seasonal changes like temperature and that sort of thing. So the traditional way of controlling the rate of change was what they called PID loops. And that is really gauged around systems that have linear responses. And a wastewater treatment plant is anything but linear, for those reasons that I just said. So what AERprocess does is it's a self-tuning type system that controls the rate of change based on what it is starting to learn about what the demand is, what the airflow changes are over the course of time of a day or a week or a month or a season. And so it delivers just enough air into the system that's needed to hit certain dissolved oxygen residuals in the system. And some of the older control systems would have like 4 ppm dissolved oxygen residual. Again, another source of wasted money, because all you need to do is satisfy that oxygen demand plus a little extra. But with the older systems that wouldn't respond as quickly, they put in a little bit of an extra buffer. Again, more wasted money. So this manages the sequencing of the blowers. It utilizes the most open valve flow-based type system, and it is what they call a self-tuning algorithm, which basically learns the variables in the system and responds accordingly. It doesn't over-aerate, it doesn't under-aerate.
Yeah. Well, and you're talking about a lot of these small minor improvements and things like that. One of those things that wastewater systems are always trying to do is reduce their energy as well. So when you think about improved DO and improved dissolved oxygen, what is the impact there on the energy side of that equation as well?
Well, compared to a system with manual control, where they're basically just manually measuring the DO, and there are still systems out there, to put in an air process can save, we've documented this, over 40% on the energy costs compared to what they're doing uncontrolled. And I spoke about the PID loop. The ones that are on PID control, we can save as much as 20%. So I mean, it's a step in the right direction to have that PID control, but if you can optimize it with the air process, you're saving even more.
Yeah. And wastewater systems also are like really oftentimes unique, almost like a fingerprint in a lot of ways. So when it comes to air process, is this a one-size-fits-all type thing, and how does that work?
It's not a one-size-fits-all. We have 5 different choices. I mean, depending on how sophisticated the system is, some of the smaller treatment plants might only have one basin. So it doesn't make sense to put all the bells and whistles on there, and we can add on more and more, like there's dissolved oxygen control with multiple basins. We actually can also provide pressure-based control if they don't have flow meters. So we can adjust our approach based on however the system is configured and whatever needs they have, going all the way up to multiple zone DO control plus ammonia-based control.
Okay.
Yeah, I mean, there are several plants that want to use ammonia-based control, primarily to control the nutrient levels in the effluent. And so that it's a little bit different than just pure DO control, but it still achieves a little bit more of a fine-tuning result. So again, to answer your question, we've got a number of different versions of this that are available.
Yeah. Now the other thing that we're seeing, we're at WEFTech, we're seeing a lot of this AI conversation as well. AI, predictive models, types of that. Like, is that something that you have going on here, or is that not something you're working on at the moment?
Well, actually, our process is different. I mean, you're doing like I said, the self-tuning algorithm that's based on measuring all of the parameters that we normally would measure in a wastewater system and adjusting to those rates of change. A predictive system is good, an AI system is good, but it's only as good as the data it's pulling. And so the thing that we have found with predictive type systems is that how do you respond to a massive upset? We have a few systems that also have a combination of municipal clients as well as industrial clients. And there was one industrial site in Maryland where we had an air process in there, and one of their industrial customers was a dairy, and they accidentally dumped like 900 gallons of cream into the system. So the BODs just went through the roof, and we were able to manage that with, again, just measuring that rate of change in the BOD or the air demand, and keep the dissolved oxygen levels from either tanking or spiking by just keeping track of those changes in the system. So I'm not saying you can't do that with a predictive system, but we find that brings us an advantage over the systems, really in the way that it responds to those upsets.
Yeah. Well, Tom, thanks so much for chatting with us and telling us all about this air process and everything. And for everyone who's watching, check out our video description below. You'll get some more information about Aerzen down there.